Good day. Welcome back, and please join in to learn with me embedded system on ARM Cortex M4 series. We are on day 3. Today it's all about introduction to ARM Cortex M4 architecture. So what is that you will learn about today? I'm going to start off with ARM overview, give you the basic overview of what ARM is about and why we go for ARM and its core versions and the architecture extensions, followed by its processor modes and what is AMBA, and we're going to learn about the architecture and the family and where M4 sits in the family. And I'm going to give you detailed explanation about each and every block sits inside ARM Cortex M4 and how the memory stackup is um, seated in M4 Cortex M4, and also the whole comparison of the Cortex series. So let's get in. Before getting into the deep end of this day, I would like to share you general knowledge about who we are. A2DG started by Anbukarasu brothers, Alex and Arul. My brother and I started this. We both have 20 plus years experience in the industry, and we would like to share that with you so that you can also be grateful to gather all the information, become successful as we are. Um, our mission is to convey at least 200,000 future professionals out there through our online learning platform so that you can study at your own pace wherever you are. Just a little bit about me. I am Arul P. Anbukarasu. You can call me as Arul or APA as popularly as I would like to be. I have 20 plus years of experience working in Australia in various industries. Some of them I listed to you here. Uh, Directly or indirectly, I have involved with the whole embedded development life cycle. So as a result, I gained a lot of hands-on experience in the embedded systems industry, in VLSI, and in project management. So as a result, I would like to bring all of that and would like to teach you so you can get valuable information from me. There is a small announcement to make. This course, this structure of this online platform comes in two different categories as YouTube viewers and internship professionals. The YouTube viewers is if you join with me and if you learn for 25 consecutive days, then you would be eligible to get an e-certificate. But the main drawback about that is the videos will be removed from YouTube channel after 3 days, so you have to be there to learn and also clear the doubts as you go along. Whereas I would strongly recommend you to enroll for an internship because that will give you all the course contents, the course materials, the PPTs, the videos, plus lots more reference links and the source code. Of course, the source code as well. And you get a lifetime validity and you'll get support from my team through the backend. So please join the internship and I'm sure you will get a lot out of the internship. Just to recap what you really require to practice and be more effective in your projects. So these are all the listed components that you would like to accumulate and start to practice yourself. But please do contact Pantech Solutions to acquire the above, and they're a cool team and they would be able to assist you to buy everything. Let's start the day today by knowing a little bit about the overview of ARM. ARM abbreviated to Acorn RISC Machines. Their architectures were developed by ARM Holdings in 1980s as a low-power alternative to traditional microprocessors. Later, it changed to Advanced RISC Machine. The ARM processors are based on RISC. What is RISC? RISC is reduced instruction set computing to make your processing simplified and make it more efficient. So that's where RISC stands for. And its architecture is well suited for low power devices. And their processors are customizable. The chips can be altered when a customer comes in and throw in to change another requirement. So it is customizable, so you can change it. ARM is only a provider of a core processor, meaning they only design RTL level design core implementation, and they're protected with their own IPs. So the other companies, if they want to use their product, then they have to purchase the core, and they can use it with their peripherals, and they can redesign them and sell it, rebrand it with their name. So that's how it works. So ARM does not fabricate silicon on their own, but they are happy to provide their code to other companies so they can make use of it. So the other companies can buy boards, debug hardwares, and the peripherals, and also whatever it's associated with the application softwares, including bus architectures. Why ARM? Why not other architectures out there? So as you know, it's a RISC machine, so it makes it more simple and efficient to use because of its wide architecture extensions on the landscape. That's why ARM is so popular for any engineering design, basically in electronics. So everyone goes for ARM, and it makes your design cycle a lot easier to do. And it comes up with all these four major advantages. It has thumb 2 instruction sets, which you will learn about that shortly. It's greatly improved code density, and also it has DSP core in it, signal processed directly with the RISC core. And Just-Sail, another extension where Java applications are integrated to it. And TrustZone, that's the main security platform where you can also have it in ARM so that your design is well secured and you won't lose anything. And also on top of all of this, the core processor, it's a performance. The speed is really fast with operating system speed of 100 megahertz. And the tools of choice that, as I said earlier, it is customizable, so you have plenty of choices to choose from. And you get plenty of wide support about anything about any project. So if you want to, you can directly approach ARM, and they are happy to help. If not, as a project builder, you can go to your project team, and they would be able to help. And also, ARM processors can work in low power consumption, meaning it can work on 3.3 volts or 5 volts. So in other words, it's power efficient. I'm briefly just showing you about the vastness of ARM, how it is all linked with other partners. As you can see in this, ATP partners with all these companies at Siemens and Wipro. You all know Wipro, Synopsys, and all this. And also they have a tool partner, so where they buy the core and use with the tools. So Synopsys, Cadence, Mentor Graphics, and to name a few. And they have a big arm in partnership with the major providers of Philips, Fujitsu, Ericsson, Yamaha, for instance, Sony. So these are all really good to have a combined partnership with real-time operating system partners and also the software partners. So in general, ARM is a big company where it is partnered with plenty of other channels to grow further into branching out to further. And also it's useful for everyone because it's all helpful in the end to achieve their targets. Let's briefly learn a little bit about ARM architecture versus the processor. I'll start with the architecture. The architecture describes the details of instruction sets, its programming models, and its exception model, and how the memory is stacked. And it has its own architecture reference manual. So if you want to know, and if you'd like to know anything about in-depth architecture, then you need to have a separate reference manual. That's called architecture reference manual. And I given you the link in the next slide. You can go there and read for yourself. There's plenty to know about architecture. And when we come to the processor is developed using one of the ARM architectures. Yes, the ARM company developed its own processor core, so that's the one we're going to use it. And in this series, I'm going to use STM32F411RE, and that has ARM processor core in it. And the processor will give you more details about its implementation, about its timing information, about various peripherals, etc. And it has also a separate manual, so you need to have both. For processor, it's technical reference manual. For architecture, it's architecture reference manual. So that's the differences between architecture versus processor. Now let's go into ARM architecture versions. What all the versions are there? So every ARM will come with a version. Starting with version 5 has JSL and VFP, vector floating point units. And they moved to ARM version 6, which is a bit higher version to version 5, which has basically both the VFP and JSL. And the ARM v7 has all the JSL VFP, plus you got the security and the thumb-to instructions and the signal integrity division in their SMID. And ARM version 8 has architecture 32 and architecture 64. This is to use with crypto. So if you go to this link, I'll show you just a sec. This is the one to show the different various ARM processors out there. And I'm going to show you about the ARM Cortex M4 series. So that's the one which has the microcontroller profile. So M stands for microcontroller, and it has a thumb to instructions, a DSPs, a single precision FPU floating point unit. So precision is really key in designing. And hardware multiply and divide instructions with optional bit banding memory. So this is the really popular processor out there in the industry. So everyone wants to have at least a project to be doing with this. That's about the architecture version. So let's um, move on to about discussing different processor families and what they are all about. Let's start off with Cortex A series. So whatever you see after Cortex, that A, R, M, likewise. So A stands for application. The application series targets mainly on the high performance processors that's capable of operating on full support operating system. For example, if you read any smart books like e-books, when you read through the amount of speed that you're flicking through the page, and for instance for smartphones, so when you scroll up and down, so how efficient that is. And for digital TVs, so you can connect your smartphone with your digital TV, so things like that. It's all application based. And next one down to A is the R, the Cortex R series. It is, as you learn from day one, it's real-time series, so R stands for real-time. And this series is targeted mainly for real-time applications. For example, the automatic braking system. So ABS, you all know about when you ride the bike, there is ABS brakes. Cars has ABS brakes, so that is one of the series they used in there. And the next one is the one we're going to concentrate in this course. It's Cortex M series. It's a microcontroller. M stands for microcontroller. It is really the best one in terms of cost effectiveness because it can be customizable for your needs. So, for example, for smart sensors and different microcontroller to microcontroller communication, Cortex M is really good. And followed by that is a secure core series, which has SC 000 and SC 300. This is for more security, like the trusted zone that we saw earlier. So they have this series for that. And prior to that, they have the basic features on single processing with limited features like ARM 7, 9, and 11. So this is the different ARM processor families, and this course is all about ARM Cortex-M4, which is the hot processor, the Gopher processor out there in the industry. Let's talk about the architecture extension in ARM4 family. As you can see, there is three different bars in there. The purple one shows the ARM, and the burgundy or some other color shows thumb2, and the dark gray shows thumb. So this is to give you a difference between the ARM instruction sets to thumb and the thumb2 instruction sets. So the ARM here, Cortex-M4 is a 32 byte, 32 instruction cycles sets, whereas the thumb and the thumb2 is different. So particularly Cortex-M4 is using thumb2 extension because it has improved core density, improved performance, and power efficiency. As you can see, thumb R has 32-bit operations with 16-bit instructions. So therefore, you have 16-bit and 16-bit is two combination to make the 32-byte. Introduced with ARM 7 TDMI, T stands for the thumb. Subsequently supported by the ARM developed processor since the early days whenever it started. And they improved by joining or improvised to thumb2. Thumb2 has the combination of both 16 and 32-bit instructions, so that's why it has that improved core density and performance. So if you see in this bar, when you compare with ARM, thumb, and thumb2, thumb2 is the best one in terms of core density and the performance. So it is 31% smaller in core density, and it's up to 38% better for the performance, overall performance. So that's why Cortex-M4 uses this M4 architecture extension using thumb2. Now let's slowly look at each and every architecture extension about this Cortex-M4. First, we start with the trust zone. The trust zone is a TE environment where your code, actually the project sits in a trusted zone. So nothing, it's like in a black box, so you can't modify or do anything, and it is well secured. And projects with highly secured applications will go for this, and it can work in various platforms and applications. So that's one of the best for security if you go for security. The next one is the Jacel. Yes, it's another Java application oriented, which can run in all Java virtual machines. It enables the acceleration of Java applications. So if your project needs any Java related things, this is the extension. You can have it. And then we're going to see what is AMBA. AMBA stands for Advanced Microcontroller Bus Architecture. It is an open standard freely available for any connection and management to functionally connect with any blocks in the SoC, the system on chip. So what is this AMBI? So the ARM core is connected with the advanced high performance bus, and that's connected to all the major ones with the memory interface, with the direct memory access interface, and with the RAM memory. So it's mainly the high performance buses are connected with directly to the ARM core. And if you want to connect to the peripherals, you have to enable the ARM peripheral bus to enable to use, for example, if you use keypad or a timer or RTC or IO, you have to enable the APB. And to communicate that, there is a bridge that's connecting the ARM core to the ARM peripheral bus. So you have to enable APB first and then APB bridge second to communicate to that. You will see that when we start to do coding as we move along, but this is the general AMBA system. So Cortex-M4 is all derived from AMBA4. Now let's see what's about the processor profile. As you already know through your research, there is a lot of Cortex M series out there. The M0 and M0 Plus are optimized for low power with the dynamic power. So the output is 13 microwatts dynamic power, whereas the MO Plus is 11 microwatts. It's only used for small projects. And then they further developed that to M3 series where they have the full thumb and the full thumb 2 instruction sets. But what it really useful in M4 is it has added on DSP instructions, which has the optional floating point unit. So you can do precise design. So that's where M4 is really advantageous. You can do a lot of video processing, image processing with the help of DSP processor, and we have other various M7, M23, and M33. M23 and 33, if you wanted to have your application to be more secure oriented, then this is the series you have to go for. So this is the general processor profiles of various Cortex M series. Now I'm going to show you about the how and where M4 sits in the family tree. As I explained earlier, M0 and M4 are for smaller projects, and their core architecture is von Neumann. As you might remember from previous sessions, that von Neumann has a drawback because the CPU can only fetch either data or program memory at any one instruction cycle, whereas the COM4 Cortex M4 is Harvard architecture, so simultaneously can fetch information from data and program at the same time, and it has a hardware and multiply, hardware divide, and saturated math, and it has its possible DSP extensions, and it has optional floating point. So this sits right up there for anyone to use cool projects. So you can include Cortex M4. Okay, before moving on to ARM Cortex M4, I think we all need a bit of a break. So I'll give you a 5 minutes break and I'll continue to teach you more in depth about the ARM Cortex. I'll see you in about 5 minutes. Go and enjoy the break.